So let us become familiar with the common graphs here. We want to both graph and state the domain of these basic functions. So the graph of f of x equals x, just x, that's a linear equation. And so that's going to be a line. And all of our basic graphs go through the origin 0, 0. So all of our basic graphs will go through that origin. Basic meaning not shifted or reflected or anything, just basic with the variable. And a line has a slope of 1, and it goes that way forever. So what would the domain be then of this basic linear function? If you look at your x values from left to right, this is continuous everywhere from negative infinity to positive infinity. You can put any real number in for x, and this comes out with a defined number. Our next graph is going to be f of x equals x squared. You see that this is degree 2, that's a quadratic. And quadratic equations are all going to be parabola shaped. So we go through the origin, and we have a parabola shape. Now, if you needed to come up with another point, you could just put any random x in here. Does it matter what the x value is? Well, let's look at the domain from left to right. This arrow says that this keeps going left forever, so that's negative infinity to positive infinity. So it doesn't matter what x we put in. If you want to get another point, say x is 3. So you get a point of 3, 9 if you needed to plot that on the MyMathLab program. Our next basic function, f of x equals the absolute value of x. And remember, we did one like that. That looked like it was V-shaped. So we go through the origin for the basic function. There's no adding or subtracting or negatives, right? So this is a basic function, and it's like a line with a slope of 1 that way and a line with a slope of negative 1 that way. And if you wanted another point, does it matter what you put in for x? If you look left to right, again, this is all real numbers from negative infinity to positive infinity. So if you wanted another number like, say, 5, you look at the distance from 5, and that's 5. The distance from 0 is 5 units, so that's going to be 5, 5 if you wanted another point there for the program. Our last graph that we're going to have to memorize here is the square root function. And if you remember, that one had a bit of a different shape. It doesn't have all real numbers for the domain because, remember, there's negative numbers that are not in the domain, because those will end up with a not real y, which can't graph. So you wouldn't have anything negative, can only be positive. And so it's going to have a bit of a restriction on the domain there. And it looks like that. So if you start at the origin, all of our basic functions do, and you have that shape there. So the domain then, for this basic function from left to right, we start at 0. And actually, we include 0, so that's included. And then we go off to infinity, which is never included. So if you want to find the domain of the square root function, you just take whatever is inside of the square root. It could be other things, but this is just a basic function. And you make that greater than or equal to 0. That will show you what the domain of that square root function is. And if you need another number, make sure it's a perfect square, like 4, for the basic function, so that you can get a square root of that to get another point there if you need it for your function.